So these expressions each define the same function without graphing or doing any calculations. Determine where the following features on the graph that represents the function and highlight where in the expression you can easily find your answer. You will have questions on the test that have you comparing between different forms, saying like which one has a higher y-intercept, which one has no x-intercept, something like that. But maybe one is in vertex form and maybe one is in factor form. Maybe one's a graph and maybe the other one's a table. So it's kind of weird that it's in this unit because I feel like a lot of the graphing stuff is unit 6, whereas this one is more like solving and knowing the steps. But it is on the test. This lesson will help you with those questions, and it is a lot of review. So table 4, what did you put for the vertex? All right, so class, you agree with that? In which expression can you easily see that? The vertex. So the one that is in vertex form, you can easily see the vertex from, right? And I don't provide you the formula for vertex form on your test. You should have had it memorized on the last test. But here it is. And what 2 letters give us the vertex, class? H and K for this setup. So the x of your vertex is always in the parentheses with the x, and it always has the opposite sign of how it looks in the formula. Because if it became a positive 3 here, that means what they plugged in, the -3, what happens with that double negative? So it always looks the opposite. And then the K, the Y of your vertex, always looks the same. And it's always not in the parentheses mean squared. It's always like separate. So there's that. Questions on that? Table 5, what about our x-intercepts? What are they? X and 6x? Can you tell me where on a graph I would find the x-intercepts? Okay, David? All right, let's see. So if they are x-intercepts, that would be where the y is 0. So writing them as coordinates, it would look like this. We're kind of on the right track, but our x-intercepts are not 2 and 4. What are they? Something slightly wrong with what we see here. They both have to be negative. And what form is this most easily seen from? The factored form, the one that's in the middle. So if it's something, I mean, technically the vertex form can still be multiplied out. But if it's something that can still be multiplied out, usually it looks something like this. It's really easy to see our zeros. So zeros, x-intercepts are the same thing. Solutions also talking about the same thing. But in that, when we were just looking at patterns, it was always these numbers, but opposite signs. And reason why is because when we set it equal to 0, so actually solving for our x-intercepts, that makes the y 0. And we set each factor equal to 0 and solve for x. What plus 2 will give me 0? Asking on one picture. You guys look like you're zoned out. What plus 2 will give me 0? -2. So that's why it's like the opposite. The So we gotta figure out what needs to make that parentheses 0. And then in x plus 4 equals 0, what plus 4 will equal 0? So that is why these are our x-intercepts or solutions. Questions on that? Okay, so then table 8, what about the y-intercept? There's only one form that we haven't like identified something from yet. It is 8. The y-intercept is 8. And if we're talking about the y-intercept, that means the x must be 0. So this is what the coordinate would look like. And the y-intercept is most easily seen in, what form is this called? In standard form. That's actually really the only thing we can easily see when it's in standard form. The constant is always the y-intercept. Or if you think like those real world problems, the starting height was always a constant. That's like the same thing, it's our y-intercept. So, there will only be one y-intercept. The x-intercepts, there can be 2, there can be 1, there can be none. And then lastly, line of symmetry. Did anyone in this class find the line of symmetry? Or can tell me what it is? Okay. Close. So you're talking about the vertex, which is also in the middle of the quadratic, right? So the vertex is in the middle. So is our line of symmetry. But our line of symmetry isn't necessarily a coordinate, it's an equation. You remember what that equation was that helped us find it? Wait, what are you gonna do? So no, you're thinking of the parent graph. But in unit 6, there was a formula I had you guys memorize for line of symmetry. No one? They have an equal sign in it. We even, I don't remember if it was this class, but I think we talked about it yesterday. You can see it in our quadratic formula, kind of. No? So let's see. I don't know how else to leave it to you. This is the formula I had you memorize. X equals negative b over 2a. And that is part of our quadratic formula. So like if I were, first of all, you probably want to write this for line of symmetry. But if I were to compare it to our quadratic formula, you don't have to write the quadratic formula right now, but it's part of it, right? It's actually this part of it. And since the quadratic formula is something that I'm providing you on the test, you can kind of look at it and remember if you need a reminder for line of symmetry that it's that part of it. So it has to be the equation of the line that goes right down the middle. You shouldn't have to plug it into this if you have one of the forms up here. Which form do you think it would be really easy to see the line of symmetry? What else goes right down the middle of the graph? So if you have the vertex form, you can easily see the line of symmetry because it's always the x of your vertex. All right, so looking here, and then also knowing that if it is in the parentheses with the x, like it always has the opposite sign of what it actually is. That is our line of symmetry, x equals -3. But if you have, say, like just a standard form, you could plug it in Like you could say your A is 1, your B is 6, and then do -6 over 2 times 1. Maybe that's easier for you. And also that will be on your formula on test day. But, I mean, up to you. It has to have the X equals up. Otherwise, it's not making a vertical line. All of these you could check with graphing, but the whole point was to do it without graphing right now. Because on your test, like you'll be comparing different forms. Maybe one of them's a table. Like maybe you're not able to graph everything that's on the test. So you have to be able to compare in the different formats. So questions on that? All right, so second to last lesson of the unit. It's a pretty long one. There's a lot of like really great examples in this lesson. So we're gonna do almost the entire note sheet. And the main goal is to find the maximum or minimum value of a quadratic, identifying all these different features of the graph. Some you already did as a warm up. And if something's written in a certain form, can you convert it to the other form? The recording is in there from last year. Not the math doesn't really ever change, but I do have to update the video every year. The practice is in Schoology, and no assessments this week. Really, no assessments next week. But next week you do have a lot of like project grades going in. So should you decide not to use your time efficiently, like your grades will tank if you don't do the things that I tell you are project grades, especially. So just make sure, you know, you still have like this week to catch up on all your missing work. Next week, all you should have to do is the stuff that I give you in class. You should have enough time to do it. But, you know, the study guides are available. You should be preparing for that last unit test. All right, so maximums and minimums. We have some equations of quadratics, and we're giving you the vertex, although you should be able to tell what they are from at least the first 3 without them giving it to you. But still, they gave you the vertex. You need to determine if the vertex corresponds to the maximum or minimum value of the function and be prepared to explain how you know. So just really quickly for each one, tell me, is it a maximum or a minimum? Maximum or minimum? And then to kind of add to that, I also want you to identify what the minimum is or maximum. So I'll kind of add that to each one. So tell me, is it a minimum or maximum? And then we're going to also identify the minimum or maximum for each one. Okay, Jalea, is the f of x having a maximum or a minimum? All right. So the way to do this without graphing is knowing whether it opens upward or downward. So class, would this one open upward or downward? It opens down because of what part? No. The A. So in vertex form, the A, whatever, and even in standard form too, whatever's in front of your x squared, so in this case, in front of the x squared or in front of the parentheses, if it's negative, it opens down like a frown. And if it opens down like a frown, the vertex is always the maximum or the highest point, right? So that is true. And then I do want you to be able to tell me what it is because, like I said, on your tests, it'll have you comparing them across different forms. So like which one has a higher maximum? You need to know that when we talk about minimum and maximum, we're really only talking about the y. Because think about all those real world examples where we compared like height and time. This is my maximum height. It's not my maximum time. So my maximum is just a 6, but I'm gonna put y equals 6 just so that you know it's just a y. Questions on that? Okay, so then the table, or actually Evan, is the next one a minimum or a maximum?
Minimum.
It is a minimum. Without graphing, and I mean, of course, on your test, if you have the time to check, please do, but without graphing, I know it opens upward because the A is positive. So that would be my lowest point then, that's my minimum. Aiden, what would the value of it be? Okay, good. Miss Medina. Okay, no problem. Bye. Okay, so it is -3 because like I said, it is the y of the vertex. Emberlyn, does h of k have a minimum or a maximum? It does have a minimum because the A is positive, right? It's a +4, it opens upward, so that is a minimum. Ashlyn, what would the value be of the minimum? 7. Good. Jake, does K of X have a minimum or a maximum? Good, that's correct. 1 second. How do the units work? Okay. Let's see. Sorry, I didn't have time to write. So K of X does have a minimum because the A is positive. Max, what would the value of the minimum be? Good, that's correct. That's my minimum Y value. Jordan, does M of X have a minimum or maximum? Good, because the A is negative. And Wade, what's the value of the maximum? Perfect. Questions? So if I asked you to compare like f of x and m of x and asked you which one has the higher maximum, you would say which one? Okay, so everyone listen, maybe we need a vote. If I asked you on the test between like f of x and m of x, which one has the higher maximum, you would say which one? Good. So you first would have to identify them on both, knowing that it's the y of your vertex, and then compare which is higher. All right, moving on. Now, I'm gonna skip this part because I mean, it's not like it's not important, but I just don't see that you would need to do this all the time. This part, maybe I'll tell you some parts. If you ever needed to convert something from vertex form to standard form, you know that standard form is fully simplified. Like there's nothing that needs to be multiplied. If I, for some reason, needed to go from vertex to standard form, first you'd have to expand this out and do x plus 5 times x plus 5. And then there was a +1 here that'll still be there. You would need to multiply that out and then just make sure it's fully simplified, and then boom, you're in standard form. So, you know, I don't think we need to necessarily go back and forth right now, but once you fully simplify it, and then this would become 26, now it's in a different form. I don't really see you needing to go from standard to vertex form that much ever, really, so I think we could just move on from there. If you needed to know, I would just say to identify the vertex and put it where the H and K are. Yeah. Moving on, we're gonna go to the part that says. Identifying key features of graphs without graphs. So again, without graphs. If you have your public open, don't have it on the. All right, so think about the features of a graph of function f without creating a graph and identify each of these bullet points. Granted, we talked about in the warm-up, like it showed you all the 3 different forms. So, for example, what form is it really easy to see the y-intercept from? Is this one in standard form? So you should be able to tell me the y-intercept right away. I won't say it right now, but like you should be able to. For the x-intercepts, what form is it really easy to see those from? Factored form. You guys learned how to factor. You might have forgotten because it's been a couple weeks, but you need to know because you have a test week after next. What is usually the first step in factoring? When I'm solving by factoring, or you don't even have to solve it right now, you're just factoring. What do I look for first? Okay, well, obviously, think about that. But you probably want to factor it to get the x-intercept. Please stop trying to cheat. We got like looking at Desmos right now. You need to be able to factor. That's a non-negotiable for the test. But that's how you'll get your x-intercepts really easily. Vertex form, like I said, you can figure out what the vertex is without necessarily graphing it. We've done that before. We did that in Unit 6. So the only reminder I'll give you for that part is that your vertex will have your line of symmetry value here. So I'll put the x in negative c over 2a. That's the x of your vertex. And the y you can get from plugging in your x. So like once you have the x of your vertex, you can plug it in and get your y. Lastly, line of symmetry, I mean that's the formula. It's in standard form. You should see the b and the a pretty clearly. I'm going to give you, I'd say, 4 minutes to identify all of those without graphing. Aiden, go ahead. Kristen, you'll be after. Aiden, you'll be after. Okay, Bella, what is the y-intercept? Negative 36, correct? And if we were writing it in coordinate form, the y-intercept is whenever x is 0, and then this is the y. So that's easily seen right now because it's already in standard form. Now, I told you that for the x-intercepts, what form is it really easy to see the x-intercepts from? The factored form. So we're going to practice factoring this. If you need to know the steps for factoring anyways for your tests. What's the first step in factoring? What do I need to look for first? The GCF, the greatest common factor. So do I have, class, more people need to be answering and paying attention. Do I have a GCF between 3, 24, and 36? Are they all divisible by a number other than 1? What number? 3. Right, your GCF can never be bigger than your smallest number. So C, is my smaller number divisible into the others? And it is. So my GCF is 3. And there's not a rule that you have to factor out like the negative or not. If this were me, I want to factor out the negative because I think it'd be easier to factor if my A value is 1. But it's up to you. Like there's ways to do it when A is 1 and when A is not 1. Like I taught you both. But I'm going to choose to factor out a negative 3, which means I will be dividing each term by negative 3 and writing that in parentheses. So like my first term will be x squared. 24x divided by negative 3 is what? 24 divided by negative 3. So negative 8x is what that one will be. And negative 36 divided by negative 3, a positive 12, so I'm going to put plus 12 there. And then to keep factoring, because all we did was factor out the GCF, which you have to do. To keep factoring what's in the parentheses, I see that it's a trinomial, so I'm going to factor it with my diamond method. So seeing what two numbers multiply to 12 and add to negative 8. Table 3, can you tell me what numbers multiply to 12 and add to negative 8? Negative 6 and negative 2. Right? Here's all the factors of 12, by the way, so if you for some reason like got stuck, here's all of them. And you have to think of any possible combination that when I add or subtract them, I get a negative 8. Now, if it multiplies to a positive and adds to a negative, then they must be both negatives. So that's how you kind of problem solve relates to that. All right, so my factor form looks like this at the moment. From this, you should easily be able to identify your x-intercepts. Table 4, what are my x-intercepts for this? 6 and 2. That's how you do it. If it's already in factor form, great. But if it's not, you'll probably want to put it in factor form to easily see that. Questions? Okay, because to make this parentheses 0, we have to do 6 minus 6. To make this one 0, we have to do 2 minus 2. So it's always like those signs, but opposite symbols. Or those numbers, but opposite sign. All right, so far this is what we have: y-intercepts, x-intercepts. The coordinates of the vertex. Let's actually start with line of symmetry, because that should have been what you used to help you find your vertex. Table 5, do we have the line of symmetry? Okay. Well, here's the formula for line of symmetry. So it should always be x equals a number, and that number you get from this, from doing negative b over 2a. Class, what's my b value? Let's go from the original. What's my b value? So I'm going to have a 24 plugged in over 2 times a. What's my a value? And we're doing negative 24 divided by negative 6. That multiplies by negative 6. So table 5, what should my line of symmetry be? And then you have to have the x equal 2. Questions on that? And remember, that's part of your quadratic formula. Like, you will have your quadratic formula on the test, so make sure, like, forget about it. The line of symmetry. And then because that goes right down the middle, your line of symmetry value should match the x of your vertex. So I know the x of my vertex will be 4 because my line of symmetry is where the x is 4. To find my y value, all I have to do is plug in 4 for the x. And you can use your calculator to simplify. Which is what I'm going to do. I'm going to use my calculator for that whole part. That way I don't have to do order of operations. And that'll give me the y of the vertex. All right, so -3 times 4 squared plus 24 times 4 minus 36. All right, so I get 12 for that. And that will be the y of my vertex. So if you got that without graphing, great. If you didn't, well, that's the process of how. Questions? Okay, gonna flip to the next one. So if you're a slow note taker, be a little faster. Okay, this one. So identifying key features of the graphs without graphing. So from a table now. Think about the features of a graph of function g without creating a graph. So your y-intercept, you can see on the table. The x-intercepts, you can also see on the table. The vertex, we've never really defined how to find it from a table, but I believe in you. You know that the vertex is the turning point of the graph, so find where the turning point is. And then your line of symmetry will be the x equals the x of your vertex. All right, so try this one. Go over it, I'd say in less than 2 minutes. Right in when Avery comes back. Okay, table 6. What's the y-intercept when it's from a table? 5 is correct. This coordinate is my y-intercept because by definition, your y-intercept is when what happens? Class? When x is 0. So if you see on a table that there's a 0 for the x, that's your y-intercept, no matter what function we are talking about. Table 8, what about the x-intercepts? One more time. Um, Incorrect. Someone else at that table? No. If your y-intercept is when x is 0, okay, -2 and +2. Because if your y-intercept is when x is 0, your x-intercepts are when y is 0. This is in function notation. You know that this is the same thing as saying y. So when my y is 0, these are going to be my x-intercepts. And depending on what snapshot of the graph they give you, maybe one of the x-intercepts isn't showing, but you will kind of base it off of where your vertex is. So table 9, which one would be my vertex? From the table. It's all my circles. So vertex. All right, so forget from a table, maybe like from a graph, how would you identify the vertex? What part of the graph is the vertex? The center point, like where it starts to turn. So where does it look like the numbers start to like turn? Asking all of you. Where? Emily? Here. So you can see it mostly in the y's, because I mean your x's are independent, like you can pick whatever x values you want to look at, but the y's are dependent, and the y's are really where you see like repeating numbers. So you see that it goes increasing and then it starts decreasing. So that right here is my turning point. That is going to be my vertex. So the coordinates of my vertex are 0, 5. And while usually they are in the middle of the table, sometimes, I don't know, depending on what snapshot they give you, sometimes it's not perfectly in the middle of your table. You have to look at your y values where they shift from like increasing to decreasing. Questions on that? So then my line of symmetry, table 1 will be what? X equals 0. Because it has to be an equation, so it has to have the equal sign. And it has to be x equals so that it makes a vertical line. But it's x equals whatever the x of your vertex was. Good questions? I actually like tables the best. They're like the most, like we really didn't do any calculations at all for this one. All right, I think that's it. Let's see what else we have. Yep, I think that's it. So if you have questions, let me know. We have a decent amount of time still to work on your practice. But know that on your test you'll be doing a lot of comparison. So like which has a higher y-intercept, which one has no x-intercepts. Like you need to be able to identify those things to be able to answer those questions.